So I'm going to give it over to him. He's going to tell us everything we know about 12-factor applications.
Okay, so this talk's kind of long, but if we can get through it within our time allotment, I'm actually going to show an example of a 12-factor auth using the ChawDev IRC chatbot, because that's designed with those principles. So first of all, who's heard of a 12-factor app? Who's actually written one? Okay. So before we get into what it is, let's talk about why it's there. So the point of a 12-factor app is it's to minimize the cost of getting a new developer up to speed. It minimizes the requirements of the underlying OS, which allows for more portability between different environments. It eases the deployment on modern cloud-based infrastructures like Heroku or Google Cloud, things like that. It also minimizes the divergence between development, staging, and production environments, and it allows for easier scaling of the application once deployed. A slight disclaimer, I cannot guarantee that anything in this talk will not make you have the following reaction. So what are the 12 factors? We have Codebase being the first one, dependencies being the second, configuration, backing services, build, run, and release, processes, port binding, concurrency, disposability, dev prod parity, logs, and admin processes. So one code base to rule them all is what Token probably would have said if he was a developer instead of a writer. But what's the first factor the code base states is your code must be in version control system of some kind, whether it be Git, Mercurial, Darks, Subversion, or anything like that. And a code base must be one single repository if it's a centralized version control system, or any of its forks if it's a decentralized. A code base is, an app is made of one code base. So if a project has more than one code bases to it, it's not an app. It's actually a distributed system made out of multiple apps. And each of these apps are they can comply to 12-factor individually. And another important rule of it, apps cannot share the same code. So if you have code that must be used between multiple apps, what you do is you factor that into a library, and then that library is handled through your dependency management, which is the second factor. So, and then, is that through twice? Sorry, I threw these together in 2 days. So the code base has only one, an app has one code base per app, but it can have multiple deployments. A deployment is anywhere that a copy of the application is running, whether it be a developer machine, a dev server, staging, or in production. And then code bases all have the same deploy. The code base is the same on all deploys, but each one can be on either a different commit or a different branch, because you don't want your production to be at the same code base that your devs are all on. So dependencies. 12-factor apps should have explicit dependencies, and if possible, either vendor or bundle those dependencies where they're in the actual code base for the app itself. By vendoring, you ensure that all the code bases, all the dependencies are actually included. There's no implicit or hidden dependencies within the application. And the best way to do this is have some kind of dependency manifest file that lists all the dependencies and what version of that dependency the app uses. A major benefit of explicit dependency management is it simplifies getting a new developer up to speed, because when they clone the actual code base, if all your dependencies are vendored, they have all the dependencies. They don't have to worry about finding out which ones that they need to pull it, where to put it, or anything like that. And if the app should not make system calls for commands or libraries if possible. If you can't avoid this, like if your app uses something like ImageMagick or curl to be able to do things, then the best way to handle that is to vendor those. So it's in your app, either as source code and gets built as part of the build stage, or as a compiled version of that dependency. In short, vendor all the things. The next one is configuration. So configuration is something that's likely to differ between deployments. As such, it should not be in version control system. So the way you there's several ways that they recommend getting around that. But in a 12-factor app, it has strict separation between code and the configuration. And configuration for things like the frameworks, routings, or anything like that are actually exempt because they're required for the actual application to run. So one way to do this is you can use configuration files that are not checked into version control system. And one example of this would be like a database schema for ORMs or things like that. And it's stronger than putting these values and things in code, but it has some weak points. These are files that are actually within the app, so they can accidentally get added into the version control system and actually committed. They tend to be scattered throughout the application. And sometimes they use different file formats. One configuration file may be in YAML, and the other one may be in JSON. And they also tend to be language and framework specific. Another approach is using environmental variables for actual configuration. And this method, there are no files to accidentally be checked in, so you remove that weakness. And they also tend to be cleaner than actually using the files method. And so
that's easy to say for developers, but like if you have to how does managing that process with environment variables work for you?
So all programming languages and all operating systems have a concept of actual environments variables, and the way you use it is you put them in the user that the application is running so it can read them. You'd have some kind of script that executes.
How do you manage that script though? Like, where do you?
So typically you can use it. I use systemd on my server, and so systemd is able to actually put in custom environment variables for a specific user. So if I have something running under a web user and I need to have an application that needs to read environmental variables, it can actually put in those for that web user.
So you do it in the
You use it in the process manager is a good way to do it.
Thank you.
And so another thing, some applications actually will group code together. And so they'll have different groups for like a development, for a staging, for a prod, and all of the developers. Like something like Rails is notorious for this. And this does not scale cleanly, and it also becomes a pain to manage when you have a lot of different of these groups in your configuration. By using environmental variables, you actually eliminate that, because instead of having different groups, they all just read from those same variables.
How do you manage the value of the variables on the different systems?
So that goes back to setting them via some process manager or something. And so
So what happens when the
then you'd need to update the environmental variable, and you can do that while the app's actually running. So because you have a way in the shell to actually export the variable, so you can export the new password or something for that.
Still have to reload the app.
Do what?
Still have to reload the app.
Yeah, you'll still have to reload the app, but
Changes.
yeah, you'll still have to reload the app for it to get that, but you just set it that way.
How does it handle our rollback?
It sounds like all we've done is moved tracking this and version control to an untracked, unmanaged, well, it's outside my development environment, so I don't really care at.
So historically, on Heroku at least, when you change an environment variable, your dynos reload live, so you actually have dynamic control over any of those fields at runtime. If you're not using Heroku, I totally recommend using a config management tool like Ansible or Chef or Puppet. You can make essentially idempotent changes over time. So if you have configuration options that need to get moved forward, you can make those changes in your repo for your config management tool, hide your sensitive settings in like a vault style structure that requires password to decrypt. So you issue that password to it, run your config management engine, and it will update on the live server at that point. So you essentially separate them into separate repositories using tools that are designed to manage configuration
Okay. So
instead of doing it in your app code base.
so you just have a configuration.
Yeah, essentially that's what I do, and then like I said, Ansible has a great tool called Vault that lets you encrypt everything that's sensitive, so like your AWS keys and stuff. You can hide all of that without other people being able to read it.
That's what I was going to ask, is you store all that separately to be part of the 12 points.
Yeah.
If it's stored in a repo, it fits into the...
You basically don't put its own app.
It's
Yeah, kind of. All right. So moving on, backing services. So 12-factor apps, the backing services, these are like backend systems. They're treated as network attached resources. So these kind of things are your databases, or message or queuing systems, or SMTP for sending out mail or caching. And what that is it should make no distinction between the service running locally or via a third party, whether it be sitting on a Heroku or an Amazon instance. So to connect to it, you'll connect to it via a URL string. So you'd have the user at and then IP address for that, instead of actually relying on a Unix socket or anything like that. And you should be able to swap out a resource without any code change. And then, so each distinct service is a resource. So if you have multiple database runnings and doing data sharding at the application level, each one of those databases is its own resource. And another important distinction is resources should be able to be attached and detached at will without having to make any changes to the code base either. And then the fifth factor is build, release, run. So a code base becomes a non-development version of it in 3 separate steps. You have the build stage, a release stage, and a run stage. And 12-factor app uses strict separation between these 3 stages. And we'll go into them a little bit in detail. In the build stage, if it's needed, the application is actually compiled to get your binary. And this is a version of the code at a specific commit or branch that was tagged during your development cycle, so tagged for release. You would build that one. And then at this stage, it should fetch all dependencies and vendor it if you're vendoring your dependencies. In the release stage, the build from the previous stage is combined with the configurations. So if you're using something to manage your configuration separately, like Chef or whatever, that will you'll pull your current configuration into via that. And then the release is ready for actual running on the production. And then each release should have its own unique identifier, either a date timestamp or an actual version number. And if you build out of release, build out for something for release and you have to make a change afterwards, you can't release it as that same one. You need to increment that always. Yeah, you can tag something for release. So as long as it's just something that everybody knows that that's what's going to be built. And then the last one is the run stage. This is the actual execution of the app. And it should happen automatically, so the app should run on server boot. If the server has to restart, it should come back up automatically, or you'd have some kind of process manager watching it, and if it dies, it should automatically kick it again. And your run stage should be as simple as possible with as few running parts as you can, so that you can minimize your points of failure within your production environment. And then our sixth one is processes. Processes should be stateless, and they share no information with other processes. And any data that does need to persist should actually be stored in a stateful resource, so a actual file system dedicated for storing those files. And then memory and local storage can be used for temporary uses, but your app should not make any assumptions that those files would be there in the future. Any asset packaging that needs to be done should happen at the build stage. So if you have a process that takes like images or whatever and actually builds it into something that can get included in the code, that happens at the build. And then any app that relies on what's called sticky sessions, they should not be used. A sticky session is storing session data within the actual memory of the server. Instead, that kind of information should be done in a caching system with time expiration. We're halfway through the 12 factors. The seventh one is port binding. A 12-factor app should be completely self-contained. And this is something that languages like PHP will actually fail at because they require a web server to be accessible. And so the app itself should be able to run and be accessible to actual traffic via port binding. So bind to a port and then start listening for requests on that port. And then because the app is has that port binding, it exposes the HTTP, and it can actually become a service for other, a backend service for other apps.
Is that the reason why you wanted to have basically be able to serve its own content, why you can't attach it to a web server?
Pretty much, yeah. So in development, you run the actual app itself, and it shouldn't rely on anything else. But on production, you can actually have it sitting behind it's like reverse proxies or load balancers, and those actually direct out to the actual app. But it shouldn't rely on like Apache or Nginx with PHP FPM or anything to be accessible.
Okay.
And then as far as
the advantage of that, that's the one I'm not really catching.
Well, the advantage is, so if you're moving to a different environment, say you were on something running Apache, and now you move to a new hosting service and they use Nginx, and your app doesn't work under FPM because it's fast CGI versus using mod PHP, that breaks it. But if it was its own app handling its own network traffic, you avoid that.
Web servers are optimized, highly optimized for handling the HTTP traffic. That means that every app I write has duplicate code to highly optimize handling HTTP traffic and scaling and whatnot.
Yeah.
You're doing that for a common interface. That's what you're getting. Like that's what this definition does. It gives you a common interface to all your apps. They all respond to HTTP. Whether or not you proxy that through Nginx or Apache
Or
or
HA proxy or something.
You can't use them.
Right.
No.
It should be able to do it.
It should be able to do it itself, but if that's not possible, then
It doesn't care where the HTTP request comes from.
no, basically.
Remove the dependencies so you're not dependent on the operating system. You can change your app, and then whatever you use as a front
Yeah.
So Drupal doesn't fit this one.
No, because Drupal's PHP, so it relies on.
The latest versions of PHP, they've got their own web server.
It has an internal, but it still needs to run that to run the app. This is versus like something like, so Go has the ability to do native port binding. Python has a library called Tornado that gives that ability. Ruby has Thin, so.
Anything to a port, that's really easy, but you're missing.
Having it listen to that port, though, that's the.
It's like GU uniform, like listening to a Unix socket
Yeah.
and then getting everything through the Unix socket.
The problem is that now I'm reproducing all the other things that Apache or Nginx does.
You know.
Yeah, I mean, Thin and
But-
Mongo, they're all HTTP and web server. Is that the only one Ruby used? WebRick is the one they used to use. They're all web servers. They all handle the HTTP, and all they really do is translate that request for the router, the routes.rb, to use and handling to which view it goes to. So you still have to include in your project, in one of your dependencies, you have to have Thin or WebRick.
Yeah. Yeah, those would be a dependency, yes, but it puts it into the actual app instead of having that external process to run it.
You wouldn't have a dependency on PHP as like, you wouldn't like pull PHP in as a dependency of your app, right? You would expect it.
But, well, no, you would vendor PHP according to this.
So you can render the web server.
Because you want this app uses PHP, but it happens to use PHP 5.3 because we haven't updated Codebase. We got a new app that says we want to use 5.5, so you have to vendor both of those, whereas the operating system only provides 5.4.
PHP
So this is like really, really interesting. I think we should debate this afterwards.
Yeah, there's still several more to go through.
I don't know math real well, but I think there's still 5 more.
Yeah. So, moving on, and if you guys want to talk about this afterwards, I'll be glad to. But the 8th factor is concurrency. So, in a 12-factor app, processes are first-class citizens, and they should take a strong example from the Unix daemons and how they actually work and handle processes, and so, and then it can assign different processes to jobs. So you can have certain processes that handles web traffic, certain processes that will handle longer back-end tasks like parsing a XML file or something like that. And then it does not exclude individual processes handling for their own multiplexing via threads or async systems. So like JVMs or event-based systems like Node.js are they're not excluded from this on how they apply. And then the app should never, or the process itself should never daemonize or write out to a PID file, instead relying on the OS's process manager or a third-party process manager to actually manage the queue and send out the tasks. The 9th factor is disposability. So 12-factor apps are disposable, meaning they can be stopped and started at any given notice. And this will allow for fast scaling, rapid deployment of code or configuration, and robust production deploys. Like this goes back to like Heroku's dynodes, where it can rapidly just kill off old process, start new ones on the fly. And then processes for the app should have little startup time as possible. This is the time between the actual process is called to when it's actually ready and working on the job it was given. And they should shut down gracefully when they receive a SIG term or some other signal. What this means for like a web process is it'll stop listening for new requests, finish off any current requests, and then die. Or if it's a back-end process, it'll actually return the job to the queue and then quit. And then they should be robust against sudden death as well. So if a process dies, you should have something there that is able to see that the job hasn't come back, either because, and then put the job back in the queue. And a lot of them will do this by either listening for or doing a timeout. If it doesn't get anything back from the worker within a couple seconds, it assumes that the process died and puts it back into the queue so another worker can work on it.
That's why you don't want to daemonize.
Yeah, that's why you don't want to daemonize. And if you wrote to a PID file, the process may not have been able to remove the PID file before it died, and so it would assume they're still running job. The 10th one is the dev prod parity. And so typically environments will get out of sync over time 3 ways. There's a time gap, there's a personnel gap, and there's a tool gap. The time gap is developers' work. It may be weeks to months before it goes from one system to another and before it eventually hits the production environment. The personnel gap, the developers will write the code, but it's actually the ops department that deploys it. So that could cause a problem if, say, all your ops are unavailable and you really need to deploy something. And the tool gap. So developers may use different tools than what's on production. So a developer may have like Nginx, SQLite, and working on a Mac, but your production environment is actually a Linux server with Apache MySQL. And so how does the 12-factor app handle this? The time gap is solved by moving code between deployments sooner. So instead of it being months before code goes from development to staging, it may be hours or days before it will go into the staging. And the personnel gap, developers are more involved with the deployment process. So it's not just your ops that are handling that. You can walk up to a developer and say, hey, we need to publish this. Can you do it? And then the last one is the tools gap. Really, your development environment should not differ greatly from your production. And there's a lot of tools that can actually make this handy. So if you are working on a Mac, there's tools like Vagrant or Linux containers. So you can actually run like Docker or something like that and run an actual environment there to do the work in. And so as a developer, you need to resist the urge to actually using lighter weight backing services. So if your production is using MySQL or Postgres or Oracle, there's probably really no reason performance-wise on your computer that you're running SQLite. Well, for Oracle and stuff, licensing, yes. But other than like licensing or things like that, that should run fine on current hardware. And then, so that covers it runs on modern day, so MySQL, Postgres, you can run it on a Mac with just a couple gigs of RAM or a Linux machine or whatever. And most package managers will actually make installing these things easier. So you can install MySQL, Maria, Postgres, or whatever through package managers like Homebrew or apt, Yum, Zipper, or Pacman, or whatever it is your system uses.
What's your 3 hour?
The next one is logs. So logs are very important, especially when it comes to production. They allow you to see what the application's actually doing when people are using the app. And oftentimes they're written somewhere on disk as a file. And the logs should be streams of aggregated time order events. And the 12-factor app really shouldn't bother or care about where the actual logs are written to. So it shouldn't worry about routing or the storage where it's going to be writing the stream to.
So you would put that in config then, like where to log the file?
The logs, the recommended one is to actually do standard out or standard error. And you can have, this way your developers can actually see the logs as they're working in it. And then in a production environment, you'll have process manager or like log router, that's what they call it. So you can have a log router that will actually see those events and write it to a file or somewhere else for you. Or you can just pipe it. So if you're running it via a cron job or whatever, you can pipe the output from standard out and error to a file.
Another reason not to daemonize.
Yes. So I know some Linux processor managers, like systemd, it'll actually see that the app's spitting stuff out on standard error, and it'll know to grab that and log it. And then Logplex, Fluent are all third-party routers that will do that for you. And then the last one is admin processes. And in a 12-factor app, admin or management processes they're excluded, they operate outside the rules of the factor 6 for their process, and they're treated as one-off tasks. The admin task must operate in a similar environment as the actual app, so it uses the same code base, same configuration. There's nothing different that allows the admin process to actually run. And the admin code must be part of the release. It can't be like an external piece of code that you have to drop in to run. The admin code does have to follow the dependency rules, though. So if it must have all of its dependency vendored, and if it requires any additional dependencies that the app doesn't need, they need to be in the manifest file as well. And the application or the environment, like the operating system, must allow the developers or ops access to the system via a REPL or a terminal, either local or remote via SSH. They must be able to get into there to run those processes or those jobs. So with this, you should be able to minimize time and cost of getting a new developer up to speed. You should be able to cut down on your reliance on your operating system, so moving between wouldn't be so detrimental. And it should ease your deployments on modern cloud systems like Heroku, Google Cloud, or things like that. It should, your divergence between development staging and production should be as minimal as possible, and allows for easier scaling. So with all this free time, maybe you can practice that new dance move that you've been wanting to learn. Move on to solving more important questions. Or just party on. So the TLDR of this talk, you can read the actual documentation for it at 12factor.net. There's also an EPUB version of it. It's fairly small. Thank you.